All right. So from Tuesday, did anybody have any questions that they would like to ask before we get started? All right. Remember to put yourself on mute if you're not talking, but feel free to chime in at any point in time. And if I can get this tablet working, we'll get started with just talking about a few things before we get to the code demonstration because we will be having that exam next week. At some point. I'll post an announcement so that they're in, so everybody will get an email about it. But I just want to make sure that everybody's aware and looking out for it. Again, it'll be just like the quiz. It will be in Blackboard. Answer the questions. You'll have all day to complete it. But as soon as you open it, it should give you the warnings and everything. But you'll only have a certain amount of time. I think probably 2 hours to do it is what we'll do. Uh, You'll have 2 hours to complete it after you first open it, but you'll have all day to actually start it. So whenever works for you. And if you still can't complete it, well, contact me. And we'll talk about it and see why. Okay? Uh, okay, so if there's nothing else to talk about there, let's jump straight into some notes. We're just going to recover some things. We don't really have a whole lot of new content to go into, but I just want to cover some stuff that we've already talked about. Like, for example, we have our relational expressions. So, our relational expressions. Now, we have a number of them, right? Does anybody want to give me one, a relational expression?
How would that be greater than?
Greater than. Okay. So, yes, we can say that a number is greater than another number. So, to tag on to that, let's just do the opposite too and go with less than, right? Any other ones that you want to think of?
Is equal to?
Equal to. Like that?
Two equal signs, I believe.
Yeah, that's right. That's right. Because just one equal sign is the assignment operator. So if I do this, this is the assignment operator. So if I say if my val equals a, and then put some curly braces here, we will always enter this if statement because this assignment will happen and this will evaluate to true no matter what. And since this will evaluate to true, we will always enter that if block. So if this comes up, remember that assignment always evaluates to true. It's the double equal sign that's going to give us the equality. Okay? And then now let's look at the opposite of that. The opposite of that is not equal to. So if something is not equal, that makes sense. There's not really a lot of gotchas there. And tagging on to these two, we can take a look at the greater than or equal to and less than or equal to. So a total of 6 relational expressions. Any questions on the relational expressions? All right, then let's look at logical operators. So our logical operators, remember we made those truth tables for these when we covered them? So first one, double ampersand. This is and, right? So and requires what's on the left side to be true and what's on the right side to be true. And only then will the result be true. Now, let's tag on to that and let's look at, well, what about short circuit? Now, who wants to give me a very simple definition for short circuit evaluation? I know somebody out there knows what it is.
Short circuit evaluation is reading basically the first expression, and if that evaluates to either true on the OR side, it will automatically count that as true, and if it's false for an AND, it'll count as the entire expression is false.
Okay. So it allows us to evaluate half the expression, but know what the answer is going to be, right? So with an AND, we can short circuit if the first value is false, right? Because since both sides need to be true, we can evaluate if the left is false, then the whole thing is false. Right? Now what about our next one? Our OR operator. Now our OR logical operator tells us that if either the left or the right are true, then the whole thing evaluates to true. Right? So, to short circuit here, all we care about is if left is true, then we short circuit as true. Since the right side doesn't matter anymore, doesn't matter, this whole thing's going to evaluate to true. And now the last one that doesn't quite fit in, but it's the not operator. And remember, the not operator is going to just invert. So whatever we do, if we have a not true, the result is false. Okay. Any questions with logical operators and our short circuit evaluation? All right, we're going to be professionals by the time the exam comes, right? Whoops.
Hopefully.
That's the goal. Okay. Let's take a look at switch case statements. So, when we covered switch case statements, we covered it with ifs, right? It was very similar. So, switch my val, and then we had our curly braces here, which that was the worst curly brace I've ever made in my life, but bear with me here. Switch my val. Then we have our case statements where we say case the number 5, for example. So this will be true. This will go into this case only if my val is equal to 5. Exactly. Then we can do something like C out. It's 5. And L. And then we got to make sure that we put our break in here. So number one thing that people forget when they're doing switch cases in C++ is this break. This break tells it, okay, time for you to exit the switch case because we're done. If you don't, it will fall through to the next case statement. And sorry, that's meant to be let me be a little bit more clear about that. This is meant to be a colon, not a semicolon. And then you can have another C out here, and then some other value. And then lastly, for our it simulates our else statement in an if else is we have our default. Default says if it doesn't match anything up here, go in here and execute this code. So we can have some code in here, and then we'll have our final break here. And you'll notice, see, I forgot my break here. So let me just Did I get it all? No, I didn't. Whatever, I'm just going to erase it. And we got to remember to put our break and then default. And then a break here as well. Now, one thing that I do want to say about it is once it gets to the bottom of the code block, just like a function or anything like that, it will exit automatically. So technically we don't need this break here, but it's a habit that I like to get into just so that I actually remember to place it in there. Okay, so what goes along with this is, of course, we have to talk about, just scooch that over. If we had the exact same thing, but as an if statement, and remember I'm just going to exert professor's privilege here and say my val is already set up, it's an integer, and it already has a value. So if my val equals 5, then we can do the exact same thing where we see out it's 5. And then we can do an else if my val equals 6. See out the exact same thing. And then lastly, to simulate our default here, if everything else is false, we'll go into an else block. And we didn't put anything in there, so I won't put anything in here. Now, these are equivalent to each other. And does everybody see that? That this is doing strict equality here by saying if this is equal to 5, in our switch case, well, in our multi-alternative if statement here, we have the exact same thing, where my val equals 5. Okay, any questions about the switch and the if? We're going to talk a little bit more about the if here in a second. No? Okay. Man, we are going to be good for this test. So we have 3 types of if statements that we talked about. And 3 types that, it's good to know that there are 3 types, but does it really matter what they're called? Not too much. But our first type, is just a regular if statement. I know, not very thrilling here, but it's just our if some expression and that is a regular if statement. Okay, second kind. A single alternative if statement. Oh, hold on one second. Resuming. Okay. So next up, so we covered our regular if statement being just an if and an expression. So only if that is true will we execute the code inside. And we don't have any alternative. Our single alternative if is, Well, same thing, just with a little bit extra here. If this expression and then our curly braces, and then we have an else. So if the expression is true, we go inside of here, and else we go inside of there. That's it. There's just one alternative path. Now, lastly, we have, and I'm just going to write it over here, our multi-alternative if. And remember, this encompasses a lot more, where it's an if and an expression, and then an else if, another expression, and then we have an else. Or we don't even need the else, as long as it's an if and an else if, considered a multiple alternative if statement, to where we have, if we have two ifs and they're all linked together, then it's multi-alternative if. And why is this important of a distinction is because this expression, as well as this another expression, I know I'm exercising professor's privilege here again, where I'm not actually going to write the expression, but just imagine it's some expression. Both of these could very well be true, right? This expression could evaluate to true, and this expression could evaluate to true. But since this is this if statement, we would enter and we would execute the code here, and then we would skip around this if statement because this is all one structure. So if you're using a multi-alternative if statement, this is the time where order of your if statements actually matters, because of just that reason. Like if this expression evaluates to true, we enter into these into the curly braces, we execute the code in here, and then we jump out and around the rest of the structure. And the same thing is true if this expression evaluates to false, and then the else if evaluates to true, then we would enter here, and then once we get to the bottom, we would exit the else. We would go right around the else statement, right? All right. Any questions about the types of if statements? Good. Good, good, good. Now let's cover two things that we've seen, mathematical expressions, right? How did we raise things to powers?
The POW, or POW command.
Okay. And what are the arguments to the POW function?
Just integer and comma power, right? Or integer,
Well,
whatever.
base,
Base, there it is.
exponent.
Exponent.
And remember, these are all doubles, right? It returns a double and it takes doubles and all that stuff. Not too big of a deal, but always remember that, just so that if we get a response from POW, we should cast it to an int or whatever we want to use it as. Okay. And I don't think that we used it in any project. Although maybe we did. I don't know why I put an E on it.
You You could have used it in the last project we did, but you could have done it without also, I guess.
Oh, okay.
Didn't necessarily say to use it, but some people probably did.
Then anybody want to tell me exactly how do we take the square root? I know that we talked about it, but it's hard to remember if we didn't, use it. So I understand. SQRT, square root. And we just input the value that we want to square root here. And again, just like POW, this is a double, and it returns a double. Okay, so raising a base to an exponent or raising to a power, POW function. Square root, SQRT. And then just pass in our number that we want to square root. All right. Now let's get to some of the newer stuff. Functions. So what are the two types of functions that we've talked about so far?
I believe void and int.
Void and int. Okay. I want some different terminology there because technically we talked about all the different data types, right? We did do a Boolean expression together. We did a Boolean expression, excuse me. I mean a Boolean function together.
Isn't it like single variable something function or something?
Yes, that's what I'm going for. SVRF.
Yeah,
Single value returning function.
there it is.
You can pass in as many things as you want to a single value returning function. It will return you one thing, one answer. Okay? So what's the difference between these two, though?
A void doesn't return anything, but an SVRF will return something to the user.
Okay. So void doesn't return anything. So no value gets passed back to the caller. Single value returning function does. Well, does that mean that the void doesn't do anything?
No, it still does something.
It still does something, but it just does the work like. I mean, let's just say that we got an example here. Print to screen. Right? We can have a void function that prints a greeting to the screen, and it doesn't need to return anything. It's just going to do that. It's just going to write a value to the screen, and that's it. But our single value returning function could be it returns a string to caller. And that string, we could choose to write it to the screen. We could write it to a file. We can do whatever with it. That's not the important thing. The important thing is that this single value returning function returns the appropriate value that we want. So we saw that with the assignment, right? Function 1, function 2, where one of them was supposed to be a void function because it was supposed to just print to the screen, and the other was supposed to return the exact same message as a string value to the caller. Does that make sense? Everybody comfortable with that? All right, I'm going to take that as a yes, and let's get to the coding portion of this. Now's the fun part. So we're going to create a new project, and we're going to just call this we're just going to call this calculate averages. and we're going to create a regular source.cpp file. And we're going to start by writing our skeleton for the application. It's doing the wrong thing. Go ahead and throw a string in here, and we're going to be doing some file IO because, oh, and don't forget that either. Fstream is used for file IO. Very important. Let's run this really quick. Make sure that it runs. It does. All right. So let me give you a quick summary of what I want to accomplish here today. So what I want us to do is write an application that allows us to read from a file. We're going to read from the file, and we're going to take all of the numbers in the file. We're going to read the full thing. So we're going to go from top to bottom, reading numbers out of this thing. There's a general mix between positive and negative numbers. And we're going to, if the number is positive, we are going to find the average of all the positive numbers in the file, as well as keeping track of how many positive numbers there are and how many negative numbers there are. And then we're going to write that to the screen once we're done. Okay, so we're combining a couple of things in here. We're going to be writing some functions to do this, and we're going to be reading the complete file. And we're going to be determining if the file actually exists. If the user inputs a file name that doesn't exist, we should just exit the application and ask them to rerun the program. Okay, so let's start with that first part, though. Let's start with the first part where we're going to try to open a file that the user specifies. So we're going to need two things. We're going to need an IF stream for our input file stream. And we're going to say that this is called DN. The other thing that I'm going to need is a string. And I'm going to call this file name. Get all that set up. So DN and file name. So the first thing that we'll do is we'll see out to the user, please enter a file to read. And then we'll do a cin file name. Okay. Now when we do, how do we open this file that they specified?
DN.open.
I like it. And then we'll pass in the file name that they passed to us, right?
Yes.
So now we can say if not DN, and then an else. Let's do this. So if not DN, this means that the file was not found. Right? Else the file was found. Okay? So we can say cout, and let's see it work first. The file name was not found. Please rerun the application. So if the file was not found, DN will be false. So this will end up being true. So the file was not found. We will see out the file name was not found. Please rerun the application. And then we will go around the else statement and then we'll end up at system pause and then return 0. So the whole application will just end. Okay. Now I don't have any data files there right now, so I'm just going to say dat.in. Dat.in was not found. Please rerun the application. Okay. Well, let me just really quick. I'm going to open this up. By the way, what I just did was just right-click on this right here, and then go to Open Folder in File Explorer. We'll just open it up like so. And now with that open, I can find where I put this file. Although we shouldn't use the whole thing. Let's just let's make another one actually. Let's make another one really quick. Actually, let me just take a copy of this. Put this in here. So we created a file called dat.in. Now I can take this file and I can drag and drop it right here, and it'll just open it for me so that I can edit it right here in Visual Studio. I got a little crazy making this thing. It was the most entertainment that I had all day. I'm just going to get rid of all but 4 values for now. And in the meantime, I'm going to grab a quick screenshot of it too. Just so that we got it. Okay. So I'm going to save this. And now if I look at here, dat.in, it does exist right next to our source code file. So if I rerun this, dat.in, it didn't say it didn't find it. I should probably output something that says found the file. Let's try that one more time. Dat.in, file was found. Okay, everybody caught up with me, or did you want me to drop this file into the Discord?
I think I'm good.
Okay.
I just hope I put it in the right place. That's all.
Well, if you dn.open it and you end up going into the else block, then you're good.
Yeah.
Okay. So we know that the file was found now. So when we get here, we are going to make a loop. Okay, let's go ahead and just make the loop first. So what type of loop are we going to do? On Tuesday, we talked about these different types of loops. There were the count control loops. And then there were the event-driven loops, which there were a couple of different types of event-driven loops. And this is going to be an end-of-file loop. Okay. So let me declare one new variable really quick. And you know what? I'll declare it right here. Int sum equals 0. And then I'll declare another int. I'm going to say that this is curval, so for current value. And so when I come down here, what I want to do is I need to do the priming read from the file. Or yeah, the priming read from the file. So what I want to do is I want to do a dn and then an extraction operator to curval. So this is my priming read. And then now I say while dn. So while there's still data in the file, we want to execute the loop body. And what is our loop body going to be? Well, we've got to do something where if the value is positive, we're going to add to sum and increment num positive. So I got to come up here and I need two more integer variables. I'm going to call this num positive equals 0 and int num negative equals 0. So we're just starting with everything equaling 0. So I have what I want to do is I want to take, we're going to just fill in this loop body here in a second. So what we're going to do is we're going to fill in this, modify the LCV first. So modifying the LCV in this case is exactly the same as our priming read. So we'll just copy and paste that in there. Boom. So priming read, we read the first value, it gets stored in curval. While dn, so if we read data into curval, we will enter the loop. We do the loop body. It's not filled in yet, but we'll come back to it. And then we modify the LCV by reading the next value. Now when we read that next value, we go back to the top of the loop and it says, well, while there's still data, so basically the question that we're asking here is, did we successfully read data from the file? And if so, continue into the loop again and then read the next line and go back up and then read the next line and then we just loop through it. Okay? Now once we're done, we're going to calculate average of values, of positive values. And then, so we need a float up here. We need a float somewhere. Let's get right here. Average. And then we need to output results. We can do that right now, so let's just do that. Average, and then we'll just say average number positive values, and then we can output num positive. Let's add one to the top too. We might as well. Sum of positive values. And we'll just output the sum. Might as well. And I'll say average of positive values, just so that we're clear. So we still need to figure out how we're going to calculate the average of positive values. All right. Well, this is a very easy statement to make, but let's make a function for determining if a value is positive or not. So I'm going to come down to the bottom here, and let's declare a function that's we're going to call it is positive. Okay, and we're going to take an integer, and we're just going to call it num, and then we'll write this expression. Now, the one thing that I forgot here in the front is what's the data type for this function? If I'm asking a question and I expect a true-false response, what's that data type called?
Boolean.
Boolean.
Boolean. Okay. So here we have our bool is positive and it takes one parameter and we're just calling it num. Okay. This is our function header. This is our function body. The whole thing is our function definition. The only thing that I'm forgetting now is to copy our function header to the top of the file where we have declared function prototypes and we just paste it there with a semicolon. That's the only additional thing there. Come back to the bottom of the file, and we can just say, well, if num is greater than 0, then is it positive? I swear, not a trick question right now. So if num is greater than 0, then we return true. Else, we just return false, because it's not positive. Now, I just want to take note that we can write this a whole bunch of different ways, right? We can have a bool, we can call it answer, and say that that equals false, and if num is greater than 0, we can set answer to a value, and then at the end we can, well, let me show that really quick. We can cut this out, and we can say answer equals true, and then just return answer. And this makes sense, right? So we start off assuming that the answer is not positive, and then only if num is greater than 0, then we set answer to true, and we return answer. Now, if it's 0 or even negative, answer is set to false. If num is greater than 0, this evaluates to false. So then we skip around this entire if block, and then we just return false. This makes sense? Now, can anybody think of an even shorter way that we can write this?
I don't know.
All right. That's fine. That's fine. If we look at this, though, right, doesn't this technically evaluate to a true or false expression?
Yeah. Oh, yeah.
So then, what could we do? Michael, I know you're so close. You're so close to it. And if you don't see it, don't worry. Don't worry. We'll go back to writing it the old way.
I'm not sure.
Do you see what I just did here?
Did you run the? Hold on.
So since it's a Boolean function, it's automatically going to return true or false based on whatever if the number is greater than 0. Is that
Yes.
how it works?
Well, since all of our relational operators, they are operators that return a Boolean value, this expression evaluates into a Boolean, and then we're just returning that.
Mm-hmm.
And again, if you don't see it, that's completely fine. I'm going to go back to the first way that we did it, and we're going to have it like that. But I just wanted to show this. And we'll get rid of that. I think that this way is a lot more clear for everybody, right? Okay. Now, the next function that we want to write is we want to calculate the average. So we're figuring out the sum of all the positive values, and we're keeping track of the number of positive values. So we can figure out the average by taking that sum and dividing it by the total. Yes? Now, what data type should that be?
Float?
Hey, I like it. And I'm going to call this calc average. And we'll say int sum and int num vals. Yeah, that seems reasonable, right?
Yeah, I have a quick question. So like for the naming conventions, are we supposed to be using camel case for these still, or for functions? Do you want them?
Oh,
Because you're capitalizing the I's and the C's.
you're right. You're right.
And
I was doing it wrong. You are correct. Because technically these should be camel case in C++, proper naming conventions and all that. Uh, Thank you for catching that. When you get into some object-oriented stuff, you'll get into that's called Pascal case. And anyways, I was in a different mindset. Thank you for catching that.
Mhm.
Okay. So no questions about functions other than naming convention. Good catch though. Okay. So if I wanted to say float answer, and our answer is going to be sum divided by num_vals, right? What's wrong with this expression though? Oops.
you have two integers that are becoming a float.
Yes. And what do we call that? Just humor me.
Coercion.
Okay. So we call this coercion. So we need to what's the word? You know, this is my favorite thing to do. And I'm doing the hand thing.
Cast.
Okay, good. We're gonna cast this. So we're gonna cast both these values to floats. And that's the only bad thing about this working from home stuff is that I can't do the hand stuff. So remember, we just write in parentheses the data type in front in order to cast it. So this sum ends up going from, let's just say, a 4 to a 4.0. And then num_vals 1 turns into a 1.0. So now we have a 4.0 divided by a 1.0. And our answer is 4.0. So we casted. There is no coercion. Now we're ready to just return answer. And that will work. And now just since I showed it for the previous function, let me just show it really quick here. We can actually take this and make this a lot smaller as well and just return this. So this will evaluate to the correct number that we want for the average, and then it will be returned, and then we're done. We technically don't even need a variable for this. Okay. One thing that I'm forgetting, we need a function prototype for this. So we'll put it up here, paste it, semicolon. Oh, and while we're up here, let's actually fix that, huh? So don't forget to fix your function prototype up here and make that a lowercase I. And I did a pretty decent job documenting everything so far, except for my functions here. So we need a purpose, we need a pre, and we need a post. So the purpose. What's the purpose for is positive? Well, it determines if the number passed in is positive or not. And the pre, well, the pre, I'm going to say none. There really aren't any assumptions. That's what pre is for. Remember, pre is what's something that we assume is true about the current state of the application or what's being passed in before the function is executed. And then now the yes.
Sorry, for an assumption, could we write like assuming that the user is inputting a number, or is that just going overboard, or is that not right?
No, I wouldn't say that it's wrong by any means. It is a little bit overboard just because of like the data type is int. They can only pass us an integer, right?
Mm-hmm.
Now, if this was a character being passed in and we were trying to like parse it into an integer, I would 100% agree with you then. Uh,
Okay.
and there's nothing wrong with over documentation. So if you put that, that's not wrong. I'm just saying why I'm not doing it
Okay.
because it's a reasonable assumption that it's an integer, right?
Mhm.
C++ would need to be broken for that not to be true.
Okay.
Okay. So the post is we're returning if number is positive. I could probably use more words there, but let's move on. So the purpose for our calc average, well, this one's easy, right? We're gonna calculate what the average is given a sum and number of values. So now this one, actually, I think that we have some assumptions coming into this. Like, for example, that the sum we are given is actually that the number of values adds up to this sum. Maybe that doesn't make sense now that I'm reading it. But what I'm trying to say is that whatever sum this is actually takes that number of values to add up to the sum, right? Because if you just send me 1 for num_vals and it actually took 500 numbers to add this up, well, I'm not going to give you the right answer, right? Were added to get to sum. Yeah, let's go with that. Num values were added to get to sum. And the post, so this is something that's going to be true after our function has ran. Float average will be returned to caller. Okay, so we've got all of our functions. I don't think we're going to need any more, but let's see. And then we'll go back up to our loop body where we left off. So I have written here as a comment to myself, if value is positive. So how can I determine if the value is positive? Well, I can call our function is positive, like so, right? Open and close parentheses, and then I'm passing as an argument our curve val. So this whole expression here is me invoking our function. If I scroll down just a little bit. By the way, the text is big enough for everybody, right? You can see it, no problem?
Yeah.
I'm asking a little late now, but... okay. So this expression returns a Boolean. And that Boolean could be true or false. So this if statement, yeah, this works, right? This will return a true if it's positive or false if it's not. So if we're in here, value is positive. Else, value is negative. Now, if the value is positive, what do we want to do? Well, we want to take sum equals sum plus curve val. We want to add the current value to the sum. We want to take num positive, and we want to increment that by 1. So we'll do plus plus. And else, if the value is negative, we're going to take our num negative, and we're going to plus plus that as well. Increment that by 1. Now, I want to show one more shorthand just because it seems to be what we're doing today, and somebody's going to appreciate it, I think. We can do plus equals, and this is another operator that basically says the exact same thing that we had before, which is sum equals sum plus curval. It's such a common thing that you just want to take a number and add it to a current number that there's a shorthand for it, and it's plus equals. Okay? So let's see here. We do our priming read from the file. While we have data in the file, we go into the loop body. In our loop body, we say if curval is positive, then we add curval to the sum. We increment num positive. Now else, if it's not positive, we come down here and we increment num negative. And then we modify the LCV, or we read the next value from the file. Then we loop back to the top and we repeat that. Okay, that makes sense. Now once we're done looping through the entire file, we have all of our values ready to go. So now we just have our last comment here that we need to fill in, which is basically we take our average equals, and let's do calc average, and we need to pass to it the sum and the num vals. Now the number of values that we counted for the sum is actually our num positive, so we'll pass that in. And there, we've calculated the average as well. Now, if I open up dat.in, I can see that we have 3 positive values. So let me take my handy calculator here, and let me do 3467 plus 1334 plus 1500. That's the sum. And now if I divide this by 3, 2100.33333. So that's the value that I'm expecting to get from this. Let's see if we get it. Dat.in. So the file was found. The sum of the positive values was, and if I pull this in really quick, you'll see that we got 6,301. That's exactly what we got there. And the average of the positive values was 2,100.33, the exact value that we got there. 3 positive, 1 negative. Okay, that's cool. That was just a simple test, right? Now let's take our big file here. I can take the big file really quick, and let me drop it in Discord for everybody. So that just in case you want to run with the big file too. There it is. I'm going to take this and replace the file and open it up, and we see that we have 900 random positives and negatives, all handcrafted. No, I'm just kidding. And let's see what happens. So apparently 395 of those are positive, 505 are negative, and there's our values. There's no way that we're going to actually go through and, I mean, if somebody does want to, feel free to go through and make sure that this is all correct. But it all seems pretty correct. So this adds up to 900. I'm happy with that. Now, what actually happens, though, if our file is empty? What if we just take all this, we delete it, save it? Now what's going to happen? So the file does exist. So we're not going to go inside this if statement. We're actually going to go in here. Our sum is going to be set to 0. Our average is going to be declared positive, negative, curve value. So we're going to read this, but nothing's going to come from the file. So dn is going to be set to false. So while false, well, so we never even enter the loop. So we come out here and we calc average for sum, which is 0, and num positive, which is 0. 0 divided by 0 might be a problem. Let's take a look. Ooh, I don't like that. So just to point this out, our average for the positive values is negative NaNInd. By the way, this stands for not a number and indivisible. So let's come through here really quick. And let's say, ooh, I just found that we have another assumption in this function, right? Our assumption is that numVals is going to be greater than 0. Or we can just account for this and say if numVals equals 0. Let's say less than or equal to 0. Return 0.0f. So you can do it either way. You could say, hey, this is an assumption for my function that you're going to give me a numVals that's not 0. Else we can just take care of it by saying, well, if it is less than or equal to 0, let's just return 0. So now if I run it, we get 0, which is technically true, right? I mean, the average is 0. There is nothing to average, so. All right. Are there any questions about this application right now as it stands? Okay. Now, the last thing that I want to do really quick, since we do have this loop built, I want to take a quick snip of it, and then we will go through this pen and paper because, well, that's odd. Because this is the exact thing that you'll have to do for quizzes and exams and all that stuff when we're talking about looping. So we're going to call this our dat.in file. So we have 4 values here. Now, this file is in, it's open. Oh, before I forget, actually, I made one mistake and nobody caught it, which is great. Don't forget to close your file. Always close your file once you open it. Okay, so we have a curve val here. We have a sum. Num pos, num neg. Num positive. Okay, so step 1. when we do this first DN, our priming read here, curval, we're pointing right here at this first value. Curval is an integer, so we're going to read the first integer in the file. So we're going to read this whole thing, and then we're going to be pointing here. So I'm going to switch to blue, and we'll say curval is negative 4959, right? So while dn, well, when we evaluate this, dn is set to true because we successfully read a line or a value from the file. So we're not at the end of the file yet, right? So we enter the loop, and then we ask if is positive curval. Well, curval is negative 4959, so that's not positive. So we go to the else, and num negative is, I should initialize these. This one is 0, this one is 0. So num negative plus plus. So that means we go from 0 to 1. And then now we modify the LCV. So right here with this DN, we're going to read curval. So it was pointing here. Now we're going to read this value from the file. So cross that out, and we'll say 3467 is stored in curval right now. And now we are going to read this value next from the file. I just like to keep track of it so that I know what I've already read. And then we go back to the top and we say while dn. Well, this evaluates to true because we did successfully read a file, not a file, excuse me, a value from the file. So we go into the loop body and we say if is positive curval. Curval is 3467. That's pretty positive. So we'll go in and we'll say sum plus equals curval. Sum starts at 0. Forgot to put that in there. So sum ends up becoming 3467. And then num positive plus plus, so that ends up becoming 1. Now we skip around the else statement because this is a single alternative if statement, so we go around it. And then we modify the LCV again. So we read the next thing from the file. So 3467 gets overwritten with 1334. 1334. And now we're looking at the last line on the file. So 1334 is in curval. We go back to the top and we say while dn. So dn is true since we did successfully read a value from the file. So we go in and we execute the loop body. So if is positive, 1334 is curval. Yep, that's positive. So we go in and we say sum plus equals curval. And remember, that's just adding to it. So 3467 plus 1334 is, I don't know why I picked such ridiculous numbers here. $48.01. Okay, and then num positive plus plus. Now I can do this math in my head at least. So that ends up being a 2. And then we go around the else. And then we modify the LCV again. Now we read 1500. So curval becomes 1500. And then we go back to the top. Now we're looking right at the bottom of the file. Now, while dn, well, this is still true because we did successfully read a line of data from the file. So that's important to note. We're at the bottom of the file, but we did successfully read something from the file. So this is still true. Now, if we go in, we'll say if is positive, curval, well, 1500 is positive. So we go in and we add to the sum. Sum doesn't matter at this point, but let's do it really quick. So plus 1500 6301. 6301 is what's in sum. Num positive plus plus, so that ends up becoming a 3. We go around the else, and then we try to read the next value from the file. Now what actually happens is nothing changes. Nothing gets read, so nothing gets overwritten in curval because we're at the end of the file. So we go back to the top and it says while dn. Well, dn is false because we did not successfully read anything from the file. So we exit out the loop down here. Okay. So we just walked through that very meticulously. It can be a little boring, but anybody have any questions on that?
Yeah, so when you get to the bottom of the file, your current value won't, it'll stay whatever the last number read was?
Yes, it will.
Okay.
Not that that's important. You shouldn't use that value again, right? You shouldn't use it
Yeah.
again.
Just want to make sure it doesn't like become a 0 or like, if we had it on a quiz, I wouldn't want to like cross it out and put 0, like if it was just reread, you know what I mean?
Yes.
Or something.
No, that's a good point. That's a good point. And it should stay that same value, but also since it's declared inside this else block here, right? This is a good chance for us to talk about scope for just a second because we got some good examples here.
Okay.
So these are the curly braces. This is the else block of code, right? We declared int sum in here, float average, int num positive, int num negative, and int curval, all within this else block, right? Once we get out here, those values do not exist. Okay, so if I do a cout num positive, you'll notice it's not even letting me, it's not even giving me a IntelliSense for it. Num positive stops existing once we get to this curly brace here because it's out of scope. Now what if I take this and instead I declare it up here with my other variables? Will it exist, or will we have the same problem? No, it does exist now. And just to demonstrate why is because we declared it here in main with this curly brace. So if I follow that curly brace all the way down, it exists throughout all this code. And this cout statement is now part of that. Okay, so I'm gonna go back though, because I like it declared there, and we don't need to cout that there. Just wanted to demonstrate one more thing with scope, because sometimes it can be really hard to come up with good examples for it. Now, what's one thing that we could do? Well, what if we forget to do the priming read? What if we forget to do the priming read? Let's go in here and let's say we have 1, 2, 3. So our sum here should be 6, and there's 3 values, so our average is 2 for this file, right? So if I run this, dat.in, there you go, positive values, 6, average is 2, 3 positive values. That all works. Now what if I forgot to do my priming read? What if I forgot to do that? Let's pretend that we had this initialized, because I'm trying to prove a point here. Okay, so we have that initialized to 0. Huh. Well, it didn't give me the exact answer that I thought. Why is that? Well, because it ran through once as, and that's not fair. I'm just now realizing since it started as a 0, that's not a negative. That's just a non-positive or non-negative value. But other than that small gap in my logic here, we're actually going through this loop body once without reading the first value from the file. So when we get to the modify LCV, we're actually reading that first value for the first time, and then we get back to the top and we execute the loop body again, and now we're actually starting to read stuff from the file. Now, what if we do what a lot of people like to do, which is taking the priming read and putting it right in here. So we can get rid of that, setting that to 0. And let's say that we don't even have this modify LCV. Let's get rid of that. So we have our priming read at the top of our loop. Will this change anything? Oh, it would help if I closed the software. Dat.in. Now we got a total sum of 9. Oh boy. What happened here? Well, we read the 3 twice. And let's take a look at why really quick. This will be the last thing that we do, okay? Take a look at this. And we'll grab our values here, 1, 2, and 3. I guess it wasn't that complicated. We probably could have just said this is the input, right? Okay, so the first thing that we're going to do is we're going to say while dn. Well, that's true, right? Because the file does exist. We didn't read anything from the file, so that didn't change. dn is true. So we enter in, and curval gets set to our first value in the list. And our first value is here. It's the 1. So curval is 1. Is positive, that's true. So sum equals, and I'm only going to deal with the sum right now. Well, no, let's do num positive too, because we'll need that. So sum equals 1. Num positive gets incremented from 0 to 1. Okay. Now we go back to the top and we ask ourselves, hey, did we read anything the last time that we read from the file? And that's true. We did. We read the 1. So we go into the loop. We go into the loop and we read the next line. And our next line is the 2. So we read the 2. Now we go in and we say, is this positive? Well, 2 is positive. So let's add that to the sum. So this ends up becoming 3. And our num positive goes to 2. So we go to the bottom of the loop. Okay, go back to the top and we say, hey, did we read anything from the file? Yes, we did. We read a 2. We're here at the 3 now. So we go in and we read the next value. The next value is a 3. So curval gets set to 3. So curval is 3. So is positive for curval. That's true. 3 is still positive. So we add that to the sum. That ends up becoming 6. And our num positive is 3. So we go around the else. We go back to the top and we say, hey, did we read anything from the file? And it's true, we did. We're now looking at the bottom of the file, but we did successfully read something the last time. So dn is still true. So we go in and we say, hey, dn to curval. Now, Drew, this proves that point because curval doesn't get changed. It's still 3. Okay? So when we go in and we say, well, is 3 positive? That's true. Sum becomes 9, and num positive becomes 4. We get to the bottom, we go to the top, and we say, while DN, well, we didn't read anything from the file last time, so we exit. We go to the bottom here, and we continue with the program. And that's why when we made that change, our answer changed to 9 and 4 values read from the file. Well, quote unquote, 4 values read from the file. Does that make sense? Any questions for me? This is your tracing of a loop. You should keep track of your variables and know how to do a end of loop, end of file loop, blah, blah, blah. All right, let me stop this.